Here we are. All right, Mark. Oh, that's not good. Let me turn this down. Okay, client-side functionality. As you know, HTML is primarily just to mark things up, to show how things should look, move things to the left and the right, make font bigger. HTML is, as far as I know, unique in the world of computing in that you don't have to write the code correctly, which is sort of insane. But you are permitted to make mistakes in the code, and the browser will try to fix it and guess what you meant, which is very disturbing, but it results in a better experience for the user in Web 1.0 when people are writing code and you're not willing to just have an error message pop up and say fix your code. You want to see the best possible rendering of it, like an analog TV set. It would just try to show you the picture even if there are defects in the electrical signal. You'll see some distorted version of the picture. But a lot of people that write, the real coders, got really fed up with that because that is for the birds. How can you have extensions in the language and other languages connecting to it when there isn't even like a syntax, and the syntax isn't even right all the time? So they wanted to use XHTML, which would be more strict. And that was the game where you would actually have to write code properly or it wouldn't render. They never really got there though, because there's an enormous backlog of HTML2 internet that will never go away, and the browsers never get to stop supporting it. So browsers are huge, sprawling, horrible monsters that try to guess what tags are missing and fill them in for you, which is part of why web designers get so many headaches, because there are so many different browsers and versions and they're all doing ridiculous things. So the same code does not appear the same in every browser, and you spend a lot of time testing your code in all these browsers, especially now with all the mobile devices. And it is really quite a challenge to make sure your page looks good to all your viewers. So click hyperlinks are the links that go someplace. You put in a URL, and when you click the link, it goes there. So that makes a request, and the request is a GET. Now it splits the URL into two pieces. It takes the, to the left, this one just had a question, read here, so it's going to put it all here. It's going to fill in this part from the current web page you're at. Now if you start this with HTTP or HTTPS, it will go to another domain. If you forget to put in the HTTP or HTTPS, like if I put google.com here, it'll try to go to the current URL and add google.com to the end of it, which usually will break it. This is a relative path. The absolute path is the one starting with HTTP and then domain.com. So you have forms, another type of input. Well, very important to us because this has an obvious way to attack the user. You put in something like a name and password, you click a submit button, and that then sends it up. Now the method up there tells it whether it's going to send it with GET or POST, which usually doesn't matter. Most web applications, even if they are written expecting POST, they will accept parameters that come in by GET. And it tells you what script you run. In this case, cookie login.php, and that's going to be a PHP or a Perl or ASP or any kind of server-side script that processes it. And this is one of the many places you get in trouble. That script, traditionally, you are not supposed to be able to see the source code of that script. So the developers frequently put in passwords and tokens and confidential logic in the script, trusting that the user will never see it, but there are many, many conditions under which this fails, and you can really see the script. The biggest, most famous one lately is GitHub. People take their code that didn't used to be on GitHub, and someone in the company says, let's put everything on GitHub and upload everything, and all that script is full of confidential stuff that developers put there thinking nobody would see the source code. But there are many other ones, early versions of Microsoft web server software, I think IIS 4 and 5. All you had to do for an ASP form is put a colon data at the end, and it would show you the source code. It was a documented feature. And there are often vulnerabilities that show you the source code. So it is a poor practice to put confidential data in the source code, but a lot of people do it. So this makes an HTTP request that goes up to the server. You can see it in Wireshark. It is just a bunch of text. The GET is there. Then comes the URL with parameters in the URL up there, and then the type of HTTP and the host name. The rest of this is not required, but you typically do have a bunch of this other stuff there automatically put in by your browser, like the type of data you'll take. And you usually have a cookie. Cookies are the most common way to mark your machine so the server knows who you are. And the cookie, like the parameters, are supposed to be in a name-value pair. So $n equals root, p equals password. That's the official standard way to do it. You can have non-standard cookies if you feel like writing an app that reads them, and it will give everyone a headache, and we'll have more about that in the next chapter. And cookies are the same. Cookie __ CFDUID equals this number, semicolon password equals that number, and on you go. Again, it's a name-value pair. although it's separated by semicolons instead of ampersands. All right, then you got these weird things called multi-part form data. Now, I don't know why they did this, but it is possible to say I want the response, I'm posting something, and I want the response to come in multi-part form data. So when you do that, the browser breaks the parameters into separate pieces down here, and it puts a randomly generated boundary token in between them. I have no idea why on earth this exists, but it is one form you will see data coming back from sometimes. That's got to be the nuttiest one I've seen, but that's one you can request form data that way if you want it for some reason, and some apps are doing it. CSS was here was a big movement. HTML was actually pretty irritating to a lot of people. It's not really a programming language, and one of the many things wrong with HTML is in the beginning there was just the internet and just Netscape, and you just view pages, but then people started having RSS feeds and small devices, and they started saying, what if we could get just the content without the form? I just want the /dot headlines and links. I don't want the ads or the images or the font or anything. So we should separate form from appearance. We should separate content from appearance. And that was the goal. So the idea was you would use XHTML and have strict content, and you would put all the appearance in cascading style sheets in a separate file, so it was easy for people that want to scrape the content and use it in some other way to get just the content without having a bunch of irritating formatting tags in there breaking it. And there was a huge push by people about 8 years ago to make everyone do this, and everyone just ignored them and kept on writing HTML2, mixing it all together because they were used to doing that and it works, and why do I care about some guy complaining and saying I should do it some other way. So it pretty much failed. But now we do have cascading style sheets as another way to format things, in addition to all the other ones, all in current use. So sort of like Windows, there are like 10 different ways to do the same thing. And so in cascading style sheets, you define another tag like H2 to have another parameter like color red. And you can define as many versions of every tag as you want. And now everything you tag with H2 will also have that parameter. And by the way, it's cascading because there are 3 places you can define the style. You can define it globally for the document. I forget the third place. You can define it inline. There's 3 places you can define it, and they override each other, and that's the cascade. Anyway, that's a detail. Doesn't matter that much for us. JavaScript is very popular. Scripts that run in a client's browser, this makes it possible to have drop-down lists and menus, and a lot of people use it to validate data. So you're supposed to type in a phone number, use JavaScript to say it should only have numbers and only have parentheses in certain spots and all that jazz, and you don't even let the user submit the form unless it passes that validation check, and that spares your server all the bother of processing all these improperly filled out forms. Unfortunately, many developers fail to realize that you cannot trust anything that happened at the client. They could have turned off JavaScript. They could be using a proxy like burp, so that after it passes the test, they stop it in burp and alter the request to violate the format and then send it on. So the fact that you write JavaScript that runs in the client's browser that says no more than 10 characters in this field does not mean at all that you can trust the input to only have 10 characters in that field. You need to check again on the server. And a lot of people forget to do that, and that creates another avenue for exploits. JavaScript has the document object model, which is a tree-structured object like a directory that can refer to every object on the page. You have document cookie for the cookie in the headers, you have document location for the current URL, and you have every form and every object on the page has a branched tree-structured path leading to it, and you can refer to it and change it. All right. The VBScript was Microsoft's attempt to compete with JavaScript, which is open source, and make a proprietary language. It only was supported in Internet Explorer. It is not supported in Edge at all. This is one of Microsoft's many technologies that they developed to try to compete with somebody like Silverlight was supposed to compete with Flash. It was just whoever went anywhere. They struggled, and then it's gone. And their phone Windows Phone appears to be another example of Microsoft trying to get people to switch, completely failing, and just pretty much giving up. And in each case, they always had a huge trumpet about how all developers should start writing in this stuff, and everyone just ignored them, and no one ever bothered developing anything, and it failed largely because there were no versions of anything worth having in Silverlight or on the Windows Phone. Microsoft keeps on barging into a market that is owned by someone else, offering something that is not very exciting, and wondering why they fail. It's very strange. Of course, I've never run a huge corporation, it's easy to throw mud on them, but they sure seem to make an awful lot of stupid decisions. Anyway, that's the document object model. You've got document at the top, then read element, then you have things like body and this anchor tag and this H1 and text down here. And you can refer to each of these things and change them with JavaScript because you can assign values to and read their values. All right. So here's a simple page with a script in it. You've got doc type is what you're supposed to have. You remove that, it doesn't really matter. The default fills in. You got header tags. You have a script down here. Then this refers to document get element by ID demo inner HTML equal hello world, and up there I have a paragraph with an ID equals demo that just closes the paragraph with nothing in it. And yet this text ends up in there because I refer to it by the document object model. And the reason to point this out is that this can be used to steal things that shouldn't be there, and one of the simplest ones is to take document.cookie and send it to a third party. This is how you do cross-site request forgery. You have a page where someone's logged into someplace like eBay, and eBay lets you put up an ad for a product. So if eBay has a cross-site scripting vulnerability, and something like 85% of all websites do, then there is some place where I can put in content and they forgot to filter out the tags. So maybe in the description of my product or the price, I can put in some JavaScript. So I put in JavaScript that says, take document.cookie and send it up to my server. And then I get your cookie, and now I'm in your account. That's cross-site request forgery, and it's deadly. And it works on almost everything on the internet. It's a little better now. There are anti-CSRF tokens that the big companies are using, like Amazon and Google and probably eBay. It's not quite as bad as it was a few years ago, but it remains a very, very big security loophole. And that's why you'll find cookies can have the HTML only tag, which means the cookie cannot be referred to in this fashion. It is not allowed to be referred to in JavaScript, and that makes it harder for someone to steal your cookie through an exploit of this type. Yeah, much better, and that's important, by the way, because the other cookie security tag, HTTP SSL only, will do no good at all. And all SSL does is encrypt it in transit so someone can't steal it, but if I can inject JavaScript, I can have you send it to my server, which you can send over SSL, and I will get it. Because I'm not reading it when you were intending to send it to someone else, I'm tricking you into sending it right to me. So a transmission security method is not going to save you. Yeah?
So what would be the methods of injecting the JavaScript? Just through an ad? Is that pretty much the only way to do that? Or?
An ad?
Yeah, how would you actually...
Oh, you just put this whole thing, script, in there. The simplest one is this one. You just, you have something like a place for a name and password. And you put in your name, and then you put in, you can do it this way. This is what you make it pop up on the screen to demonstrate the vulnerability. That's the one I do a lot just to see it. What you'd have to do here is make an HTTP request, including it. And I've got projects where you do that. You set up a server, you make a request to the server, and you put the cookie in a parameter. And then you fetch it and the logs off that server. So it's actually quite effective. And it violates the same origin policy. I'm able to take you or you're on Yahoo, and I can take your Yahoo server and send it to evil.com because I asked for it. Like I say, the same origin policy is at the heart of all browser security, and it is very porous. There are many ways to defeat it, and that is one of the big problems. All right, so then there's Ajax, asynchronous JavaScript and XML, which apparently has grown somewhat beyond this definition. But anyway, you now have scripts that can load part of the page. And I was sort of interested. I know Google upgraded to HTTPS only. So I didn't think I'd be able to see this, but I was, because if you go to a Google site, let me get my Wireshark up. Okay, if you go to a Google site and you try to look at maps moving around, let's start with that one. If I go to maps.google.com, see, this is the first big use of Ajax that I knew about, was Google Maps, which was bloody awesome. You'd have a whole map, and then, let me make this thing shrink if I can figure out how. Oh, good. And then you would drag it, and only this part loads. It doesn't have to load the whole page every time you move it. It can drag it, it can load just an inch on this side, so that's fine. But the problem is, if you drag it, there's the code that's loading it. I saw it go by. It's TLS. It's purple. It's encrypted, TLS application data, because Google is 100% HTTPS, and they have been for about 2 years. So that means I can't see what's going on in any detail in Wireshark. So I thought that was going to foul up my demonstration, but it didn't, and that was an educational lesson. I found this one, links 3H and 3I, it's one of them. The links are down here. Yeah, this is it. 3H and 3I, I think. Yeah, this is some other non-Google website, findmapsfast.com. It is not HTTP, and I thought, well, this will work, and indeed it does. Let's start by sniffing again. All right. And so I'm sniffing over here, and by the way, I found a query string that will show us only the good stuff, which is HTTP and frame contains get. It will show me nothing but HTTP gets. So let's put that here. Frame contains is my favorite thing I learned from the Wireshark certification class. That makes it easy to really see what you need. So now it's only going to show me the requests which are Ajax used to make this map. So right now the map has already been loaded and you're not seeing anything, but if I drag it around, there it is loading just this part. And just that part, and that you can even see it. This part stayed there, and that part fills in about a half a second because it loads. That's Ajax, which makes it much better. And you can see the requests here, which I thought was fine, but the thing that annoyed me is these are coming from Google. So what's interesting is, and you can see here's what these Ajax requests look like. Let's follow the TCP stream to see how they look. The URL has this long list of parameters. PB equals all this hogwash, and token equals this. It is an appropriately formatted parameter list, but inside this parameter is a whole bunch of data in some format. This is something like latitude and longitude and zoom factor or something encoded in this data somehow. But the thing that got me is it's coming from Google. So even though Google is HTTPS, their API, the application programming interface that lets other people use their services, does not require that, which of course makes it more useful because many other people have not upgraded to HTTPS yet, and they would like to continue to use Google services like advertising partners. It's really not okay to force the whole world to move to HTTPS just because Google could afford to, and that's what they do. But it does mean that Google services are not really all being delivered to HTTPS. Through their business partners, they're being exposed to HTTP, and that's an interesting vulnerability that could perhaps be used against them. I know it happened to Bart. Bart turned off some cell phone repeaters, and Anonymous got really mad, and they wanted to hack Bart, and they couldn't hack Bart, so they found a Bart partner site called mybart.org that was less secure, and they hacked them and dumped out the credit card numbers, which resulted in harming Bart customers and defaming Bart, even though they didn't hack Bart. And that is a fundamental security problem. Most people have many business partners, and they affect your reputation, and they have some access to your customers' data, and you don't really have a way to make sure they are secure, so your attack surface is bigger than you think it is, and part of it is out of your control. So it's an issue. This is why when you start securing companies, one of the first questions you ask is, you define what your most important assets are, and now tell me how many copies are there of that file and where are they? And most people have got no clue at all. It's on my server, it's on Amazon instances, it's on Azure instances. People have it on their thumb drives, in their Dropbox, on their home machine, on their cell phone. I couldn't even tell you how many copies there are all over the place. They say, well, you got to tighten that up, or you're never going to stop people from stealing it. Anyway, so.
Isn't that a compliance part?
Yes. If you have a regulated industry, then you have to have a better answer to that question. If you're something like health data, this is why if you can't put health data on Azure, because Microsoft says specifically in Azure instances that they can't even tell you what country it's in. It's just a giant geo cluster. Amazon has a special HIPAA compliant version of AWS that costs more money, where they do guarantee where it is, and they guarantee to treat it in conformance with HIPAA. And that's what you'd have to do if you didn't want to be out of compliance. Yeah.
You hear about the Facebook finally had some HIPAA stuff?
Oh no, Facebook has HIPAA stuff?
Well, it shouldn't be, but it was basically a psychiatrist.
Yeah.
Their patients started getting recommendations to friend each other
On
Facebook through the psychiatrist.
So psychiatrists have like a Facebook social group or something?
I think it was just a Facebook page. But
Oh.
the
Yeah.
TLDR was like possible HIPAA.
Yeah, that's the issue. I mean, boy, I sure hope they're keeping medical data off Facebook. Facebook has got so many problems, I don't think anybody on earth would regard it as HIPAA compliant. Anyway, that's the fundamental thing so many people do is they put stuff on the internet and then they don't want everybody to see it. Don't do that. That just doesn't make any damn sense. But anyway, all right, so especially Facebook, because every couple of years they decide to just let everybody see your stuff in defiance of the privacy promises they made. They just do it over and over and over. This is like, how many times does someone betray you before you finally quit trusting them? Anyway, so JSON is another way to do it, JavaScript object notation, and the idea here is it's formatted in a way that fits neatly into JavaScript scripts to define variables. So you have a name and value pairs separated by colons and commas and with these curly braces around it. It's just another way data is returned. This is very popular for cell phone apps. You log in, then it wants to download like your profile picture, and it does it with JSON or something. It downloads little facts about you fast. It has the same effect as Ajax, that you don't need to load a whole page. You can ask for just a few bits of information and get them fast. All right, and if you want to update data, you do it the same way. You send it a post request, and in your data, you just have one of these JSON structures with the curly braces and the name value pairs. It's just another way to format it, but you need to be aware of this, and it'll be more obvious why you need to know all these details in the next class when we talk about fuzzing and attacking these things. You have to make scripts that will send many requests, and you have to know exactly what format it wants to see them in. All right. So like I say, the same origin policy is at the fundamentals of almost all browser security. This is why you have separate cookies for every domain. And the idea is content from one website can only read and modify data in the same domain. So if I'm at Amazon, I can open up another tab that is details about the book, and I can buy the book, and that will be interpreted as part of the same session, so I won't have to log in again. But if I open a Facebook tab, it won't have any access to the Amazon data or cookies, so if somebody puts a malicious post on Facebook with scripts in it, won't be able to steal my Amazon account and buy books. And if it does, that's cross-site scripting, where scripts escape the correct environment and somehow move over into the environment where they don't belong. And there are many, many, many vulnerabilities that keep popping up allowing that. Yeah?
What about the logging from one web page, for example, Facebook or Twitter or something, GitHub, to another web page?
Well, unfortunately, normally your login is stored in the form of a cookie, and the same origin policy supposedly means the cookie can't go somewhere else, but unfortunately people connect them, like log in with Facebook. So now you give some other group like LinkedIn permission to use your Facebook credentials, and they do that with OAuth if they do it right, but many people don't do it correctly. See, OAuth was designed for this. So if I'm some other site like LinkedIn, and I want to let you log in with Facebook, Facebook will send me a token. I send you to Facebook. You log in over there. I never see your password. Then Facebook sends me a token that tells me you are logged in. And I can do something like make a post on your wall or something. And there's a list of permissions in your Facebook account saying who you've approved to do what. But a lot of people don't bother to use OAuth. A whole bunch of, especially phone apps, just don't use it. They actually handle your password, collect your password, and then forward it to Facebook, which is very unsanitary. And but there is a mechanism, but that's, I think, the most common problem. People get hacked through these connections, and they end up with connecting some stupid counter and how popular are you on Twitter and how influential are they. They have like 50 things they've connected they forget about, and some of them have weaknesses, and people come in through that. So, I mean, if they handle a cookie improperly, or you handle a script improperly, you can directly steal it, but in the normal business events, most people have turned on a bunch of stupid things and forgotten about it, and those are open doors. Yeah?
Do you favor like tokens like JWT tokens over cookies?
I wouldn't make any sweeping generalization like that. I mean, I think they're all fine if you handle them correctly, and if you make mistakes, they're all disaster. I don't think it's as simple as choosing one over the other. And it's certainly my position is not usually developing new stuff, but auditing existing stuff. And there you have no choice, right? People use all this stuff, and you have to see what they did and whether there's a problem in it. So my immediate interest is just so we know how they all work. But yeah, it would be nice if there was just a secure method you could all use. It was better than the others, but I don't see any sign of that at all. Except with a few exceptions, like there's no excuse for Java and Flash. So bad, the Flash is almost gone now. Just endless exploits and problems and performance. A few things are just so terrible people actually give up on them. But the rest of them all seem to be up to the skill of the developer. All right, so that's the official same origin policy. If you're on one domain, you can make an arbitrary request to another domain, like submitting a form, but you can't process the data returned from that request. That's the game here. A page can't load a script from another domain, and a page residing on a domain cannot change a cookie on another domain. However, it is very easy if you are at an insecure site like AOL.com for me to trick your browser into thinking it's AOL when it isn't. One of the simplest techniques is to just run a malicious DNS server and give you the wrong IP address for AOL. And if it is not an HTTPS URL, your browser will not notice it and cheerfully go to my fake AOL page and cheerfully hand over all the stored cookies and passwords and everything. thinking it's talking to AOL. That's why anything sensitive should be going over HTTPS, which among other things ensures that you are in fact talking to the right company. Anyway, all right, so HTML5, I introduced new tags, and it's largely replacing Flash. It's a whole lot easier to display active content like movies and such. It has new APIs that may have vulnerabilities. It modified Ajax, which is XML HTTP request is the main thing, to allow two-way cross-domain interaction. So that'll come up in a later chapter, and that introduces a new category of attacks. And it has more mechanisms for client-side data storage. Now, the king of this is Google. Google bought DoubleClick, and their primary business is spying on people, and they don't want you to ever stop that. So they invented Flash cookies called browser helper objects and many other things, and they find many, many ways to mark your machine with a tag that you can't find and you can't delete. And clearing your cookies does nothing. And if all else fails, they use your IP address, and that's how they make all their money. And this is legal. The head of Google said they'd push it right up to the creepy line, but no further. But the further you push it, the more money you make, and that's why Facebook keeps doing it over and over. They want to connect you to more people to get more information to put ads on the site. That would be worth so much more money that it's worth tricking you. And every company has an endless temptation to do anything to get more data out of you by fair means or foul. So this is the issue of what they so-called Web 2.0, where instead of just having companies and professional web developers putting up pages, you now have, and you put up content and it just sits there, your customers are now adding content to the page. So people are putting up product reviews and blog posts and comments on things, and that means you're not just publishing stuff, you're taking amateur contributions from everybody and echoing it back to other people. So now you've got an obligation to clean it, or you're going to be taking malicious content and helping people attack other people, which is what happens all the bloody time. So you've got a lot of cross-domain integration. Typical page loads things from 30 or 40 different domains now. All these technologies running on the client side. And like I say, now your users interact with the page more, so it's great for people who want to make friends and have chat rooms and games and everything, but all those are security risks. And all these browser extensions are enormous problems. That's why more and more people are just trying to move away from these browser extensions. Extra code added to your browser that is just notoriously insecure. Like there's never been a secureable version of Java in about 8 years, although it's gotten better about 2 years ago. From a period of like 7 years ago to 2 years ago, Java was just a wide open door, and I had it in the hacking classes like the second project to take over a machine with Java. It was trivial. You just deliver a Java applet that gives me remote control of the machine. It's not even an exploit. It's an existing command, and it would just cheerfully do it. Then, after Java had been humiliated for about 5 years by this, they started turning on security measures that prevent that by default, which just means to run whatever Java your company has written, you have to turn that stuff off. But that's the same thing happened with PDF readers and everything else. But anyway, all these objects are more and more restricted. More and more when you go Flash or anything comes up in a browser, your browser says, this stuff has Flash, do you really want to run it? You probably shouldn't run it. If you're going to run it, you have to update to the latest version every time you open your browser, just to irritate you, to make you quit using it. And the idea is with HTML5, you really shouldn't need this junk anymore, and it's all pretty much becoming extinct, I think. Except for Java, of course. Java will never die, Java will persist, but not in the form of Java applets in a browser, in the form of Java on the server and Java on the client, on the Android client. The language will continue, but these Java applets in the browser are on the way out, I think. Anyway, you have to have a state. Like you log in, and there has to be some record kept of the fact that you've logged in. So you need stateful data to compensate for the stateless HTTP. You therefore have to have a server-side structure called a session, which indicates that you are now not just the same as a user that just connected, you are a user who is connected and logged in, so you will get different treatment. When you go to the email page, instead of seeing a login page, you're going to see your email and nobody else's. So this has got your stuff, and some state data is stored on the client, because you have to keep re-identifying yourself with every single request, because HTTP is forgotten, so something has to be passed up as a token to prove who you are. All right, I got a few of these iClickers. Come grab one if you don't have one. Leave your name behind with something unimportant. Yeah.
Did you stop sniffing?
Sniffing? Oh, I don't know. I might still be sniffing. Let's see. I could very well be. Looks like I didn't. Might as well. Otherwise, it'll probably, because that's one fun thing about Wireshark. If you let it run, it will actually fill up your RAM and crash your machine. It's also insecure. You can take over the machine through Wireshark if you run it as root. That's one of the many security jokes. If you use Linux, every time you launch Wireshark, it says, I can't see any interfaces. You have to run me as root. Then when you run me as root, it says, don't run Wireshark as root. It's not safe. So those are your choices. So anyway, there's a lot of things like that. And this is why you have to have sympathy on all the poor developers that do something dangerous, because they want to actually get the job done and not get fired today. And if you don't present them with some choice that is reasonably possible, they will just do it the wrong way to get through the day. I'm no different. Anyway, all right. So, which item sends data like that? Should be listening.
It's not listening.
It's not listening? Well, how rude.
Oh, you can test it.
Well, I did. Try it now. How
Who's got their
rude.
SDR going?
What's that?
Oh, that thing in
that shit don't work. Did you try to lie?
Software.
Let me stop it and restart it. I'll pull this plug out and restart it. I don't know. Maybe it's not any better than the old one. Actually, that's not going to do any good. Now it's